Okay, exercise 16 from this tutorial. From figure, well, the figure is given here, and compute the length of time required for the average grain diameter to increase from 0.03 to 0.12 millimeter at 600 degrees centigrade for this brass material. Repeat the calculation at 700 degrees centigrade. So you can see that in this figure the the data which is given to you is between the grain diameter and the time, and both grain diameter and the time are represented on the logarithmic scales, and different curves have been given which show the condition of this brass material for different temperatures. So this is 500 degrees centigrade, 600, 700, 800 and 850 degrees centigrade. And then as you can see that for a given time the grain diameter increases with increasing the temperature. Okay, so for the first part we have been asked for 600 degrees centigrade. So we need to just read the values from this graph. So for this, what you can do is you can draw the horizontal and vertical lines and then place those vertical lines at the appropriate locations. So for example, this horizontal line you can place approximately at 0.03. So now you can see that the value which you have with this horizontal line at 0.01 and the next horizontal line is 0.01. So you have to estimate where is 0.03. So I mean approximately from here, or if you have some ruler, then you can measure the distance and then can locate 0.03 on his. And then for the value of time you can use this vertical line, so where it is intersecting this 600 degrees centigrade line, so it's approximately here, and then from here you can read this value. So the time given over here is in the logarithmic scale, so you can see that this value is 1 minute and the next value is 10 minutes. So this may be approximately like 2 minutes or 3 minutes, etc. So if you do this manually, so you have to read, you can read these values, but we have the interactive graph. So I can go to this interactive graph which I have placed, the link of this I have placed in this shared file. So this is the interactive graph for that. So from this interactive graph I can move this horizontal line to 0.03 millimeter. Okay, now it is showing me 0.03 millimeter here, and then I can move this vertical line to here, and now it is showing me the time value of 5.62 minute. Okay, so I have for example over here so for part A I have time t1 and then diameter d1. Diameter d1 is 0.03 millimeter, and for this I have got the time is equal to 5.62 minute. So time is equal to 5.62 minutes, and the d2 I have is 0.12 millimeter, and what will be t2? T2 will be the time which we need to read from here, from this interactive graph. So I move this horizontal line to 0.12 millimeter. So 0.12 millimeter is here approximately, and then I move this vertical line to its intersection to somewhere here. So I can read this value over here. It is 245 minute. So T2 will be 46 minute. So let's take it like 6 minute. Okay, and this is so the time needed. So time needed for the diameter to increase from 0.03 to 0.12 millimeter will be equal to 246 minus 6. That means 240 minute. Okay, so this is the answer for part A. And part B, repeat the calculation at 700 degrees centigrade. Okay, so the same values for the 700 degrees centigrade. So what will be time T1? Time T1 will be for diameter 0.03 millimeter. Here 0.03. Yeah. So for 700 degrees centigrade. So in fact, this line is not intersecting. So I can say that if I just expand this line, so it means that it will be like the initial time will be somewhere very close to here, so it will be about 1 minute. Okay, so you can take it as 1 minute. 1 minute. And then T2 will be for 0.12 millimeter change. So 0.12 is here. 0.12 is here, and then what will be the time on 700 degrees centigrade line is just here. Yeah, so it's just here. So it's about 10.4 minutes. So this time is 10.4 minute. So the difference between this is 10.4 minus 1, so it's about 9.4 minute. So as you can see that there is a very big difference between these two times at different temperatures. So this is for 600 degrees centigrade, and this is for 700 degrees centigrade. So you can see that at elevated temperatures the grain growth also accelerates quite a lot.